Hello, welcome back to another video. Today I'm going to show you how to make a 3S battery pack, which brings it up to 12.6 volts fully charged, and we are going to use salvaged 18650 cells. These are from Power Tool batteries, which I've taken apart and fixed up, cleaned up, and rewrapped. And this is a really cheap BMS from Temu, AliExpress, Amazon. You can get them anywhere. This is specifically for a 3S pack. And if you've seen my other videos, this is a capacity tester. So what I've done is basically done a discharge test on each of them. As we can see, this is 1847 milliamp hours, and the internal resistance is 49 milliohms, right? So I need to check the internal resistance of each of these because I forgot to, and that's pretty easy with this device. I don't have to do a discharge test. I'm just going to chuck it in there. Negative's that end, so put it in like this. And here we see the internal resistance, 59 milliohms. I'm going to write it there. And the lower the number, the better it is. Okay, the higher the number, the higher the internal resistance, which isn't good. So I'm going to do that for all of these. And then I'm going to show you this website, which shows you how to configure a pack. And we are going to use these 18650 cell spaces, and we're going to build a, well, it's going to be 3S, but we're going to have 7 in parallel to fit one of those little boxes, which I'll show you over here, which is also, you can get these from AliExpress, Temu, and yeah, basically what, like those little lead acid or lithium iron phosphate battery boxes. So it fits neatly in there. And then we've got this is a 3S charger over 2 amps. We have a switch. We have a capacity monitor, which is configurable, by the way. And then because it's a 12 volt pack, I'm going to use this USB device. It gives you 2 USB ports. And it takes an input of 12 to 24 volts. Output is 5 volts at almost 5 amps. And we're going to try and cram it all in here. I think we can. The batteries come up to about almost to the top, a little bit of space, probably about a centimeter of space. So with this can just be mounted on top. It's a surface mount thing. The charger, I might be able to just sneak it in the lid somewhere, and the same as the switch. But we'll see how we go. But the main thing about this video is building the pack here. So I'm just going to show you that in this video, and I'll loop you in once I measure the internal resistance of all of these. Okay. Here is the Cell Saviors pack builder, and here we can get some advice on which cells to use for our salvage ones. So here I got salvage cells, and we're going to click cell capacities with IR because I have the internal resistance. It says here, enter a comma separated list of cells with the capacity and IR value separated by a colon. Okay. This is something I did earlier before, but we're going to start again. So for each cell, I'm going to go 2330. That's my first cell. And it has internal resistance of 45. Right. Then I go on to the next one. 2245, 2245, and 43. Okay, so I'm going to do that to all my cells here. I'll come back and I'll show you what the next step is. Okay, I've entered that all in there. So the capacity and internal resistance separated by a colon, and each cell separated by a comma. And we're just going to copy that because I don't want to lose it and have to retype it. And then I click next step. And here we have what we are going to have in series. So 3 cells in series. With series, the voltage adds up. And number of cells in parallel, 7. Each cell is 3.7 volts. Generate pack. And here we go. So with my cells, I'm going to get just over 15 amp hours, which equates to 166.522 watt hours. And there's a maximum divergence of 37 milliamp hours. So what we have here, we get given a group, so 3 groups, because we're having 3S pack, and here it's going to tell us which cells to use. So each capacity of the series group, it's about 15,000 milliamp hours. So it organizes it for you, tells you which way to configure the cells, making them all kind of as equal as they can. All right, so I'm going to build the 3S7P pack here and then find the cells, and I'll show you what it looks like. Okay, there's the bottom cell spacer. So just to visualize it, the BMS is going to be sitting on the side of the pack. So if we imagine, so you got 0 volts there, 0 volts to 4.2, so that's basically one battery there, right? Okay, so we're going to put, all the batteries on this side from, I'll drop the BMS, negative to positive, all the way that way. And then we're going to put it upside down, so positive facing down here. So that means I can join all the positives to the negative there. And then we'll have the same orientation on the last row. So when I have the nickel strips from all the 4 sides, they all match up here. Okay, so 0 to 4.2, and then the last one over here, second last one, 8.4 volts and 12.6. This will make sense once I put it all together, which I'll show you shortly. So to make it easier, I've put them all on the table here, and it's like a game of bingo. You got to look for your cell. So the first one, 2330 milliamp hours and 45 milliamps, which is this one. And then we place it there. And then we check it off and go to the next one. Tedious process, but we'll get there. Okay, all these cells are now loaded in, and we've got the spacers. So, pretty heavy. I'd say it's almost a kilogram in weight, and pretty good for 15 amp hours in here. I think when I see SLA batteries, they're about 12 amp hours, and lithium iron phosphate. LiFePO4 batteries are obviously they're a lot lighter. My tongue's tied there trying to say all those words. So here we've got the negative and the positive. So it's all one string. And then we have it the other way around. So negatives at the top, and then flip it back the other way. So positive, negative, positive, negative, positive, negative. So we'll just visualize this first. When we're joining batteries in series, so we've got negative to positive, negative to positive, negative to positive. So we're joining it like this. Down, up, across, down, across, up. So if we look at our BMS, 0 volts. So we're going to start here, right? 0 volts, that's be negative. And then the first positive, that's going to be 4.2 volts at full charge. And then we have to join this positive to negative, and then we join this positive to negative here, and if we measure from here to here we get 8.4 volts, and if we measure from here to there we get 12.6 volts. You can smell the nickel burning. Okay, another strip. Make sure you only have one. Go across from the other side so you don't accidentally short stuff. Okay, let's just check again. I'm checking this so many times, but it's better to be safe than sorry. So we've got a whole negative line joined up together. It's got nothing on there. And then we've got, oh gosh, let's double check again. Yep. So we've got all our negatives joined together, all our positives joined together, and then this battery is joined to the negatives here, and then we've got positive here and then negative there. So we need to join the negative to positives here. This side is all finished. So if we cover it up with Kapton, we reduce the risk of shorting things. And yeah, because I've done this before, accidentally drop it across that shorts and it's bad. So I'm learning from my experience here. Cover up one end once it's finished. Of course, you can get nickel strips that are already made in the configuration like this. But I just have a plain roll, so I have to do it this way. I have to cut it up individually. But I guess it's actually a bit safer because you got to think about what you're doing before you actually chuck it on there. So from here to here, 4.16, okay, and then if we go down to here, we get 8.4, which is good. If you come to here, we should get over 12.63, and that's our pack. And then all we got to do to finish off this pack is stick this BMS on and solder up the ends to it. So I'll do that off camera and then I'll loop you back in. And it's working. Yes, we're getting 12.61 from the input and output of the BMS, which means it's working. Alright, the pack is complete. Wrapped it in Kapton tape. There you go. And some Barley paper on top and the bottom, just for extra protection on the terminals. And one final check of the leads here. As you can see, it's 12.46 volts. So it's all good. So this will be the main terminals, which will be used to charge and discharge the pack. And that is how you complete and build a 3S7P lithium-ion battery pack from salvaged cells, using a website which shows you how to group them according to the capacity and internal resistance in the best possible fashion. And this is 15 amp hours, and I think, what did I say, 155 watt hours, something like that, but I'll put it on the screen for you. There we have it. Hope you enjoyed it, and I'll catch you in the next video.